Okay, I've posted the original problem over here just for completeness, but we'll talk through the problem by looking at this diagram. Okay, we have this oil refinery right here that needs to ship its oil or get its oil via pipeline to some tanks on the other side of a river that is 2 miles wide. And it's also a horizontal distance of 8 miles from the refinery on the other side of the river. Okay, and the cost of a pipeline over land, which is $200,000, is half as much as the cost underwater, which is $400,000 per mile. Okay, and we want to minimize that cost. So it looks like, well, we want to minimize the cost by saying we're going to have this point P at some distance X along the North River bank, and then we're going to go the rest of the way underwater. That's the cost we want to minimize. So the cost function looks like this. For every mile of pipeline we lay over land, that's 200,000 times X. And underwater, this little distance right here is 8 minus X, because the total distance was 8. So by the Pythagorean theorem, this is the distance that we'll be laying pipe underwater. So the cost of the pipeline underwater is 400,000 times that expression right there. And it turns out if you find the derivative and set it equal to 0, that X equals that number right there approximately. So we want to go 6.8 some miles down the river on the North River bank to point P, then start going underwater. Okay, the question is, how do you find that number right there? Okay, and I also want to make the observation that as long as the cost underwater is twice the cost over land, you get the same exact number for X. And let's just go to Desmos for a second. What happens if we don't have any pipe over land? Well, the total cost there is 3.3 million. And the other option is just to go, well, come on. Let's set it like this. Is to go this way. You could go all the way to here and then go down. The cost underwater is 2.4 million. So there is some minimum value between 0 and 8, it looks like, that's going to give us a cost less than the endpoints. So it looks like 2.29 million. Okay, so let's go back to Wyzant and see how we do this. So here's the cost function right here. We're using 2 and 4 for the costs instead of 200,000 and 400,000, but the result would be the same. In the end, you would just multiply by 100,000 to use the cost function with 200,000, 400,000. Okay, so C prime of X equals 2 times, think of this as to the 1/2 power. 1/2 of 4 gives me this 2 times, well, I'd reduce this exponent by 1, which puts the radical in the denominator, times the derivative of the inside chain rule. And we want to know, when does this derivative equal 0 to find the critical number or numbers. So if I set it equal to 0, I can see that every term is divisible by 2. So that's what I've done here just to make the calculations a little bit easier. I end up with a radical equation, which to solve a radical equation, we isolate the radical and then square both sides. So That's what happened up here. Squared both sides. Got now a quadratic with values for A, B, and C using the quadratic formula here. If you simplify this number under the radical, you actually get the square root of 48, which is 4 radical 3, and then every term is divisible by 2. This number is outside the bounds of x being between 0 and 8. It's too far down the shoreline. So there's an exact answer. 24 minus 2 radical 3 all over 3. Okay, hope that gave you some ideas. Pause the video, take some notes, see if you can duplicate. If you have any questions, post a comment.